Graph Theory Class 5 Video 3. In this video we're going to talk about isomorphic graphs. So let's begin with a theorem. This theorem goes into more details on the specifics of what I was saying last time about how isomorphic graphs only look at the mathematical structure of the graph. Okay? So in particular the theorem says isomorphic graphs have exactly the same structural and mathematical properties. In particular, isomorphic graphs have the same number of vertices, the same number of edges, the same degree sequence, the same number of connected components, and the list goes on. There's more than just this. This is just some examples of similar mathematical structural properties which isomorphic graphs share. Other things that you could add to this list are stuff like if one graph has is Eulerian, then if another graph is isomorphic to it, it has to be Eulerian. Okay? All of these mathematical properties are preserved under isomorphicness, under isomorphisms. So if one graph has a triangle hidden inside it, then an isomorphic graph has to also have a triangle hidden inside it somewhere. What I want to note now is that it's actually quite difficult to show that graphs are isomorphic a lot of the time. Usually it's a lot easier in showing that graphs are not isomorphic. Okay? It tends to be easier to show graphs are not isomorphic because, for example, you can just find a mathematical property which one of them has and the other one does not. So for example, if the graphs have a different number of vertices, if they have a different number of edges, or if they have a different degree sequence, then they can't be isomorphic. So let's see this in an example. So this example just says, show that the following graphs are not isomorphic. Okay? And you could you could spend a lot of time trying to find an isomorphism between these. It's not obvious that they are or are not isomorphic. So I think the best thing to do is to check all the simple criteria. Do they have the same number of vertices? Well, on the left you have 1, 2, 3, 4, 5, and on the right you have 1, 2, 3, 4, 5. So they have the same number of vertices. Do they have the same number of edges? 1, 2, 3, 4, 5, 6, 7 on the left, and on the right 1, 2, 3, 4, 5, 6, 7. So they have the same number of edges. Now this isn't a necessary condition this isn't sufficient for them to be isomorphic. Okay, so we can't conclude anything yet. Now maybe let's turn to the next criteria. Maybe let's look at degree sequence. So if I work out the degrees, that's degree 2, 4, 2, 3, 3. And on the right, the degrees are 3, 3, 3, 3, 2. So the degree sequence of the one on the left is 2, 2, 3, 3, 4. And the degree sequence of the one on the right is 2, 3, 3, 3, 3. So they have different degree sequences. Okay, so they're not isomorphic. And it's as easy as that. Okay, they have different degree sequences, so they're not isomorphic. This is what I mean by sometimes it's easier to show that they're not isomorphic than to show that two graphs are isomorphic. Let's do another example. Okay, show that these two graphs are not isomorphic. So again, start with the easy criteria. So the one on the left has 6 vertices, the one on the right has 6. Okay, how about edges? The one on the left has 1, 2, 3, 4, 5, 6 edges, and on the right has 1, 2, 3, 4, 5, 6 edges. Okay, let's work out degree sequences. Well, if you think about it, all of the degrees here are 2. And on the right, all of the degrees are 2. So they actually have the same degree sequence. But that's not sufficient to conclude that they're isomorphic. Okay? Just because they have the same degree sequence does not mean that they have to be isomorphic. the implication doesn't work that way. It's just if they have a different degree sequence, then they're not isomorphic. So how can I show that these things are not isomorphic? Well, it's sort of like almost a trick question, because I purposely drew this graph over here in a misleading way. If you think about it, I can separate this graph into two disconnected graphs. This graph on the right isn't actually connected. It's two triangles just sitting on top of each other. It just maybe tricks you into thinking it is connected. So the graph on the left has one connected component, and the one on the right has two connected components. Okay? But if they were isomorphic, they would have to have the same number of connected components. So they are not isomorphic. Okay? And that's it. So let's try and do one more example. These examples get harder every time. Okay, so this one's going to be a bit tricky. Well, obviously, in this case, they're both connected. They both have one connected component each. They both have 6 vertices, and they both have 8 edges. Maybe I'll work out the degree sequence. 2, 3, 3, 2, 3, 3, 2, 3, 3, 2, 3, 3. Okay, so the degree sequences are just 2, 2, 3, 3, 3, 3, 2, 2, 3, 3, 3, 3. So they have the same degree sequence, okay? But like we said last time, that doesn't necessarily mean that they're isomorphic. So what can I do now to prove that these are not isomorphic? Well, I need to think about other mathematical properties which one of them has and the other one doesn't. And one particular mathematical property is like the existence of a triangle. So notice that in the right I can draw this triangle. Okay, I can draw a triangle right there. But on the left graph there are no triangles. This isn't a triangle because this isn't a vertex. It's just a crossing of the edges, but it's not a vertex. So you can't do this. There is no way of drawing a triangle on the left one. Every time you try, it takes at least 4 edges to go back to the beginning. So the existence of a triangle on the right one but not the left one means that they are not isomorphic. Okay, so the left graph has no triangles, whereas the right graph it has triangles. So they're not isomorphic. Okay, and that's the end of this example. These sort of questions showing that two graphs are not isomorphic, there's just a standard inventory of tricks that you have to test. Test the number of vertices, test the number of edges, test the degree sequence, test the number of connected components, test to see if you can find a triangle or a square in one of them but not the other one. Test any sort of mathematical property which you can find in one and not the other. And that's how you answer these sort of questions asking you to show that two graphs are not isomorphic. That's the end of this video.